Hello, and welcome back to a video series on MAT 1033 Intermediate Algebra. This is video number 38 in the series, Factoring the Greatest Common Factor. My name is Dr. Sean Perry. Before we dive into polynomials, let's recall what greatest common factor means for numbers. The greatest common factor of a collection of whole numbers is the biggest number that evenly divides into each number in the collection. In other words, it's the biggest factor they all have in common, hence the name. Let's look at some examples. The greatest common factor of 8 and 12 is 4. 4 is the biggest number which divides evenly into both 8 and 12. For 6 and 12, the greatest common factor is 6. 6 actually divides into 6 to give you 1, and it divides into 12. 1 is the biggest whole number which will divide evenly into both 11 and 12. Finally, we could look at collections larger than 2, and what we require is that it divides evenly into each one. So for example, if I looked at 8, 10, and 12, the biggest number that divides into all three of them is going to be 2. Now, given a polynomial with more than one term, we might ask precisely this question about the greatest common factor of its coefficients, which are the numbers that come in front of each term. So for example, in the polynomial 7x squared plus 14x plus 28, it makes total sense to ask, what's the greatest common factor of 7, 14, and 28? In this case, 7. Since 7 goes evenly into each term, we could actually divide it out, factor it out to the front, because really, each term could be written as 7 times something. 7x squared plus 14x plus 28 has a 7 in each term. We could factor it out front and write this as x squared plus 2x plus 4 times 7. So notice that there's a 1 here, that was 7 divided by 7. A 2 here, that's 14 divided by 7, and a 4 here for 28 divided by 7. And this expression is factored. It's been written as a product. It was just a sum before, a sum of terms, of monomial terms, and now we've written it as a product of this polynomial, 7, not a very exciting polynomial, but a polynomial nonetheless, and this polynomial, x squared plus 2x plus 4, which is simpler than the original one. So now let's shift our focus to talking about the greatest common factors of the variable part. We're looking for the largest power of x, if x is our variable, that can be divided from each monomial in the polynomial. So let's say we were considering x cubed, x squared, and x to the fifth. Well, the biggest power of x, which I could divide into each of these without making a negative power, is going to be x squared. So in other words, if I divide each one of those, x cubed, x squared, and x to the fifth, if I divide it by x squared, this is the biggest thing I could divide it by without getting something that wasn't a polynomial over here. Here, I divide something by itself, I get 1. Here I got x for x cubed divided by x squared, and here I get x to the third for x to the fifth divided by x squared. If I had chosen any larger power than squared, like third power, then this would have been x to the minus 1. And as we saw, that's not technically a polynomial. So we have to divide by only so large a polynomial that it doesn't go over. If we pick the bigger power here, then technically the exponent of this term would become negative, and that's not a polynomial. So this leads us to a kind of funny way to state the conclusion of what is the greatest common factor of a series of variable terms, a series of variables raised to powers. Given a group of positive powers of x, the biggest one we can divide out of all of them is going to be the smallest power given. Note in the example, x cubed, x squared, x to the fifth, x squared was the smallest power, which means it's the biggest power that we could divide evenly from all of them and still get a polynomial term. So that's sort of a shortcut to thinking about the greatest common factor of the variable part. You can just look for the smallest exponent of x that appears, and that's the biggest one you're going to be able to factor out. So let's put these two facts about coefficients and about variables together with a numerical example. Here I have a polynomial 6x squared plus 12x cubed plus 9x to the fifth. And we can factor a greatest common monomial out of each one of these and write it up front. But first I have to answer the questions. What is the greatest common factor of the coefficients? And the greatest common factor of the coefficients of 6, 12, and 9 is going to be 3. 3 is the biggest number that divides evenly into all of them. And what is the greatest common factor of the variables part? We have an x squared, we have an x cubed, and we have an x to the fifth. Well, just like before, the greatest common factor of these is going to be x squared, the largest one we can divide out without going over. And we saw before how this gives us 1x and x to the third. 6 divided by 3 is 2, 12 divided by 3 is 4, 9 divided by 3 is 3. And so if we put these two facts together, we're going to be able to divide out the monomial 3x squared from our original polynomial. That's going to look like this. 6x squared plus 12x cubed plus 9x to the fifth. We could factor out 3x squared from each term and get 2 plus 4x plus 3x to the third on the inside. Notice that we can check our work here to make sure that we factored correctly by redistributing. If I bring this back inside, I should get exactly what I started with, and I do. If we take a look at each one of these products pairwise, we find the original terms in the polynomial. That's a good time for critical notes. I want you to copy this, show it to me later as proof you watched the video. When you are factoring the greatest common factor, the greatest common monomial really, out of a polynomial, you want to take the greatest common factor of the coefficients. You want to take the smallest power of x that you see. And then you want to divide that term from every term in the polynomial and write it multiplied up front. In other words, we want to factor or reverse the distributive property here. Now that also includes if the smallest power of x is just x to the 0. If you don't see any powers of x in one of the terms, if it's just a number, then 0 is the largest power that you could factor out. So I said positive powers before, but perhaps I should have said non-negative. Now, factoring the greatest common factor is one of the few exercises that is simple enough that you could actually do it for polynomials with more than one variable. So with some x's, y's, and maybe even z's thrown in there. And so because it's easy enough, it's just the distributive property. It gets no trickier if we add more variables. This is one of the few exercises that they're going to ask you to do that has a multivariable polynomial to work with. So let's see an example of one of those. Here I've got a jolly one. It's 4x squared times y plus 10x squared y squared plus 8x to the third y to the third. Now, the reason that this does not get harder is because we can keep looking at each one of the parts individually. We can look at the numbers part, coefficients, we can look at the x's part, and then we can look at the y's part all separately and then combine that into one answer. So for example, the greatest common factor of 4, 10, and 8 is 2. The smallest power of x was this x squared. Here it repeats, but that's okay, it's still the smallest. And the smallest power of y, well, there's a single y here, so that's y to the 1. And what this tells us is that I could factor out 2x squared times y from each and every one of these terms. If I do that in the first term, I get a 2. The x and squared and the y cancel completely, and 4 divided by 2 gives me a 2. If I do that from the second term, 10 divided by 2 is 5. X squared divided by x squared is x to the 0, or no x's here. And y squared divided by y just gives me a single y. Finally, I do 8 divided by 2 is 4. X cubed divided by x squared is a single x. And y cubed divided by y is y squared. So here we have factored, or written as a product, this polynomial of two variables. All right, that brings us to the praxis for the day. Let's do some practical exercises. I want you to factor the greatest common factor out of each one of these trinomials. So, pause the video at this time and give each one of these a shot. Okay, let's see how you did. So the first one says we have 6x squared plus 2x plus 4. I can't pull an x out of everything because this guy's missing a 4, but I can pull a 2 out of everything. So I divide 2 from 6x squared, I get 3x squared. I divide 2 from 2x, I get x, and I divide 2 from 4, I get 2. We write them as a product, and that's the end. Here I've got 10x squared plus 15x cubed plus 20x to the fourth. The biggest number I can divide from each number is 5. The biggest power of x I can divide from each x to some power is x squared. That's the smallest one. So I write that up front, and then the rest of these terms I'm going to divide by our greatest common factor. So 10 divided by 5 is 2, and x squared divided by x squared is no x's. Just 1 goes here. Then we've got 15 divided by 5 is 3, and x cubed divided by x squared is a single x. Lastly, we have 20 divided by 5 is 4, and x to the fourth divided by x squared is x squared. And we're done. For the last one, let's take our time with this. We want to know what is the greatest common factor of the coefficients of 12, 16, and 20. It's 4. What is the smallest power of x? There's an x squared I could take out. What is the smallest power of y? Well, there's also a y squared right here. That's the smallest power of y. So I could take out 4x squared y squared, write it up front, and then we divide that from each term in the polynomial to get the other factor. So 12 divided by 4 is 3. X squared divided by x squared goes to 1. And y to the fourth divided by y squared gets y squared. Plus 16 divided by 4 is 4. X cubed divided by x squared is x. And y cubed divided by y squared is y. Minus 4 goes into 25 times. X to the fourth divided by x squared is x squared. 4 minus 2 is 2. And y squared divided by y squared is 1. Something divided by itself is 1, so it disappears here. And this is our final answer. All right, that's it for this video. Thank you for your patience and have a great day. Good luck with your studies, and I will see you in the next one.